about length, area, volume, mass. Our last topic in this unit is density. What exactly does it mean? Yesterday I passed around the block of gold and the block of balsa wood. Which had a greater density? Caitlin? Block of gold. So what does that actually mean, though? So if it has a greater density, what are you really saying about that? Habib?
How much the object is filled on the inside?
How much it's filled on the inside? Okay, that's one way to think about it. Ryan?
How easy something can go through it.
Okay. Brandon?
Like atoms are packed in.
Okay, how much matter is packed into that size? And in the gold, there are many more molecules packed into that little space than the balsa wood. So how does it feel?
Heavier.
Yeah, for that same volume, it feels heavier. It has a greater mass in the same volume. Okay? So density is the amount of matter in a certain space. Or you could think about it as how compact the molecules are in a substance. That's what density is. How compact the molecules are. How squeezed together. And when we talk about density for various materials, for a pure material, for example, this is aluminum. Aluminum is a metal, an element, and it has a certain density. The density of aluminum is 2.7 grams per cubic centimeter. Okay? So all pure aluminum has a density that's close to 2.7. And it doesn't matter the size or the amount of material. A tiny little speck of gold has the same density as a huge chunk of gold. If I had a piece of aluminum 10 times this size, I'd have the same density as this aluminum bar. If I chop this aluminum bar into 3 separate pieces, would the density of each piece be different? No.
No.
But it's 1/3 as small, it's 1/3 smaller. But the molecules, their spacing, the compactness hasn't changed at all. And because of this fact, we can use density as something called an identifying property. Which means if you have some unknown metal, unknown material, you can find its density and then use that to figure out what the identity of that metal is. If you just had some shape and you weren't sure what it was, what metal it was, and you find its mass and you calculate its density and you find that it's 2.7, you can be pretty sure that that material is made out of aluminum. And aluminum's density is 2.7. So we have a chart that we'll be using later on in this section that lists the density of various materials so that you can use it to identify what they are. Density is also important in objects floating or sinking in liquids or gases. A less dense object will float in a gas or a liquid that's more dense. With this block of aluminum,
Looking for Mr. Archery.
one room over.
Oh yeah, but that's like a sign.
Oh, he's in the computer lab this period, 113. You know what that is? It's the one right there. So this block of aluminum, if I put it in water, will it float?
No.
No, it will not. But this block of balsa wood will. What's the difference?
The matter, I mean the
The
density.
density. Aluminum is more dense than water, balsa wood is less dense than water. Will this block of balsa wood float in the air?
No.
Why not?
Because air doesn't have density.
It does have density.
Just very low.
Why won't it float in the air?
Because the air is more dense.
This is more dense than air, therefore it won't float. So, less dense objects will float in a gas or liquid that's more dense. Okay, helium is less dense than air. So when you put helium in a balloon, it's less dense, and that's what causes it to float.
What about the balloon? Like
The mass of the balloon? The difference is enough that it can also keep the balloon afloat. The helium is such a lower density than air that it keeps the plastic or the foil of the balloon in the air as well. All right, and then number 3. So density for objects remains the same, but one thing can alter the density of objects, and that's temperature.
Doesn't that go against what number 1 says?
What? The density of something at a given temperature
Oh,
is the same. So, like I said, the density of this aluminum at 20 degrees Celsius is 2.7 grams per cubic centimeter. But if I heat it up, its density will change. Do you know what will happen to its density?
It'll turn into a liquid.
Well, before that, even if it stays a solid, as you heat up an object, Kimberly,
If I get less,
its density decreases. The molecules
separate.
expand. They get less compact, and therefore their density drops. So temperature can affect density. As you heat up an object, the molecules expand, making it less dense. This is why a hot air balloon works. In a hot air balloon, they heat up the air inside of the balloon, making it less dense than the air around it, causing it to float. Natalie?
Wait, so then how come above we said density of a substance at a given temperature does not change?
At a given temperature. So that means the density of this at 20 degrees Celsius is always going to be 2.7.
Oh, okay.
But if I change the temperature, I can change the density.
Wait, so there's like a point where
And almost everything expands when heated. Okay, so almost everything's density will drop as it's heated. That's why those density charts that tell you the density of this, it always lists the temperature too. So these are the densities of these materials at a certain temperature. Yes, it will not change. At a given temperature, aluminum's density is always the same. That's number 1. Number 3 though says, if I do change the temperature, its density can change. That's why I have to add, that I didn't just say the density of a substance does not change, right? Because it does change with the temperature. But besides temperature, it will always remain the same.
So, 20 degrees Celsius, that's the given temperature?
Yeah, like on the chart, if you look in your notes here. Yeah, look up ahead, the back of 34.
I just thought you meant when you said given, you meant heat up.
So you see that chart?
Yeah.
It lists the density of various materials, but what does it say at the top of each one?
so is this?
Yeah, at 20 degrees Celsius. So you have to give that temperature, and if this block of aluminum were at some other temperature, it probably wouldn't match up with that. All right, now we're going to be calculating the density of objects. And to do that, we need 2 pieces of information. The mass of the object and the volume of the object. If I have those 2 pieces of information, I can calculate the density of the object. All right, so let's review. What is volume? The definition. Matt?
how much space an object takes up?
The amount of space an object takes up. And what is mass? Juliet? Yeah, the amount of matter in an object. What formulas do I use to calculate the volume for different shapes? Kayla?
For different shapes or for shapes?
Well, for whichever one.
Well, for cubes and rectangularism means length times width times height.
Yep. How about a cylinder?
Pi r squared height.
Exactly. Yeah, so I use a couple formulas. Length times width times height, or pi times radius squared times height. Jimmy, is this about the density and the temperature again?
Yeah.
Go ahead.
No, I was gonna say that. Did you make this packet?
Is there a mistake?
Yeah, it
Yes.
says
Yeah.
dynasty.
Yeah, Mr. Arcuri typed that on.
Dynasty word.
Yeah.
So density with density.
Yeah. There's no formula for mass. I'll tell Mr. Arcuri about that. Maybe he'll fix it for next week. Units. What units do we use for volume? There's a few of them. Habib?
Milliliters,
Milliliters. What else? Ryan?
centimeters squared,
Centimeters
cubic.
cubed. Or liters. And for mass, we use grams, kilograms, milligrams. When we're actually measuring it, what equipment do we use to measure volume? Sophia?
Well, it depends on what you want.
Right, so what are some things we use?
Well, a graduated cylinder if you're doing water.
Graduated cylinder, or if we're using math, we would use a ruler. I mean?
Are we gonna get our laptop?
No. How about mass? What tool do we use? Kimberly? Not for mass. Kayla?
Triple beam down.
Triple beam balance or scale? Alright, so let's now talk about density. So density is how much matter is sort of squeezed into a given space. How compact. And we have a formula we use to calculate density. Formula for density is mass divided by volume. D equals m over v. Take the mass of the object, we divide that by the volume of the object, and that gives us the density of the object. D equals m over v. Can anyone guess what units we would use then? Caitlin?
Liters, milliliters, centimeters,
Well, we use it sort of them combined in a certain way. Juliet? What's that? Not just grams. Habib? What's that?
Milligrams?
Nope. Kimberly?
grams,
Nope. Matt?
gram per centimeter squared.
Close. Very, very.
Cube.
Yes. Grams per cubic centimeter or grams per milliliter is how the units that we use for density. It depends on how we measured the volume and mass. So it's a unit of mass slash a unit of volume. And the equipment we use is just the equipment we use to measure the mass and volume. Density is just a calculation. We aren't measuring it directly. All right, now, if we look at the formula, okay, density is how tightly packed the molecules are. Okay. The formula we use for it, density over 1 equals mass over volume. And what this means is that if we have 2 out of the 3 variables, if I have mass and volume, you can figure out density. If you have density and volume, you can figure out the mass. If you have the mass and the density, you can figure out the volume. Because you could always solve for that one unknown variable. So let's think about this for a second. You have a piece of chocolate. Let's say it has a mass of 100 grams. Okay? If I break it in half, now it has, and I have just half of that chocolate bar, its mass is less, correct? So why doesn't its density change? Juliet? You're on the right track, Habib.
Even if you split it, the density will still be the same because if you combine them, it's still the same.
True, but now I only have half. Its mass is half as much. So if you look at the formula, shouldn't its density decrease, Ryan?
No, because how compact the molecules are, it still looks the same.
You're right, but I'm thinking about, Brandon, what are you saying?
The volume changes too.
Right, because now I have half the mass, but I also have half of the volume. And when I do the math, it's going to come out to be the same density. Okay? All right, now we can use, we'll do that problem later. So the last thing I need to go over with you is solving for the unknown. So for example, this is the formula you're going to use. Density over 1 equals mass over volume. So let's say I have a material, I have 100 grams is its mass. And its volume was 20 cubic centimeters. What is its density? Brandon?
5 grams per cubic centimeter.
Yeah. Density equals 100 grams divided by 20 cubic centimeters equals 5. And now units. Grams per cubic centimeter. Grams divided by cubic centimeter. That's its density. Okay, pretty simple, Habib?
Why couldn't they just have D instead of D over 1?
Because you can, and often we'll just write D equals M over V. But the D over 1 comes in handy when you have a problem such as this. Let's say I have an object with a density of 2 grams per cubic centimeter, and I have 15 cubic centimeters of it. I want to know how much mass is it, what's its mass going to be. So again, if I give you any 2, you can solve for the third by using this proportion. So let's set it up. So D over 1 equals M over V. What are the things I know?
That the volume is 15.
I know the volume is 15 cubic centimeters. Do I know the mass?
No.
No, so I'll keep an M.
Oh. Then the density is 2 grams.
The density is 2 grams per cubic centimeter
And
over 1. So how do I solve that?
M has to be.
Rosemary? Okay, what do we say? What's that method? Cross multiply?
Yeah.
So 15 times 2 is 30. 1 times M equals M. Okay. The centimeters cubed cancel out. Mass is 30 grams. Let's do one more. So now let's say I tell you I have 30 grams of something. And the density of this material is 12 grams per cubic centimeter. What's the volume of this? How do I set it up? B,
Replace the formula with, substitute the formula with the numbers.
yeah, so what do I know?
The P.
Know the density is 12 grams per cubic centimeter. How about on this side, what do I know? Mass, which is,
30 grams.
and I don't know the volume. Okay? So how do I solve that?
Cross.
Cross multiply, so what do I get?
Um,
12 grams per cubic centimeter times V equals 30 grams. How do I solve for V? You guys know algebra? You guys know how to solve for this? Yes? No? Right?
Divide 30 by 12.
Yeah, I divide this by 12. Divide this by 12. Yes, get the variable alone. And so what do I get? 30 divided by 12, what do I get? 3.5? 2.5. Is that what you said? Sure. 2.5. Alright. Alright. Or do you do it this way? Do you just do volume goes up here, 12 goes down here? When you cross multiply? You could do it in different ways. Alright. You're gonna have to do that on tomorrow's homework. Okay, let's put that away. This is your mass of solids lab you're gonna be doing.